So I wanted to implement the split and merge algorithm in MATLAB. It turns out that it's a little bit easier said than done. It takes a little bit of work to really get it to work right, and haven't really fully got it to work the way I want it to yet. But I'm gonna stop working on it. But I kind of want to go through and show you some of the things that I did to make it or get it to be where it is, and some of the things I had to change. So I kind of rolled back to my first iteration, and each quote-unquote scene is going to be where I make a new change and kind of try to address problems. So you can see how I work through that. So starting out, I've got this command, and all this does is clear things out. I've got an error threshold, which is basically I work until all my points are within this distance of a line. This is something that is used later, but I basically say a line has to have at least 2 points. And I could define that and say a line has to have at least 5 points. That's something I actually use later. And then here's my point data. So I have a point at 211, 311, 411. So you can see this is a straight line going across y equals 11. And so I just kind of, what I did is I made that in Paint first, and then I figured out where those point coordinates were at, and I transferred it into this array. And then remember, the point of something like the split and merge algorithm is to consolidate your data, so you don't have a bunch of points. You have instead just description of lines. And so the way I describe my lines is actually with 2 points. So it's really 4 data values, right? An x1, a y1, an x2, and a y2. And this greatest distance, that's just something I use to keep track of where my split point is for lines. And then this is just something I could have did this like when I initialized my point. When I initialized this, I could have added this information in there, but it's just easier to do it with code. And that is that there's a couple extra values. So the third column of this array, so right here you can see this is really a 2-column array, but if you imagine there's a third column, a fourth column, and a fifth column, I'm going to fill those in. The third one is indicating what line that point belongs to. So I decided to go through and assign lines to each point. It kind of helped with the way I was trying to implement the algorithm. And then the fourth column, I set all those values to infinity. And what this is a placeholder of the distance from that point to the line that it belongs to. So I'm storing that. And then this is something I use later in a different version of the algorithm, where I store if it is an endpoint. And this is where things kind of started to get goofy, and I gave up. But so it's 0 if it's not an endpoint, it's 1 if it's an endpoint. And if it's an endpoint, that means that it shows up in this line data array. So now we can kind of get into, not quite, but we can start to get into the algorithm a bit. And that is, we want to find which 2 points are the furthest away. So I basically go through and I find the distance. I basically compare each point to every other point. And so this isn't super efficient, because if I had 1 billion points, I would have to do 1 billion times 1 billion comparisons. So it's not super great, but for this kind of smaller case, it works to find the 2 points that are furthest. And then what I do is I take those and I store them in the first row of my line data array. So I basically say this is the first line that we're starting with. And now is when I can really start running the algorithm. So remember, I want to work until my greatest error is less than an error threshold. So that means that once all of my points are close to a line, that means I can stop. So the first thing I do is I go about, and this just plots the lines so that I can actually see each iteration, which is really helpful to kind of debug this and make sure things are working right. I set my greatest error equals to 0. My outlier, I think that's just a variable there. It's not super important. And then what we do is we go through and find each point's distance from the line that it belongs to. So starting out, everything belongs to line number 1, or that first line that we found. And we find its distance from that line. And once we find the line with the greatest distance, or the point with the greatest distance, we take that point and that line and we split it into 2 new lines. So we take the endpoint, we take the 2 endpoints and we assign those, one stays in the line and one goes to a new line, and then the new, the middle point, or this kind of split point that we found, becomes the endpoint for both of those lines. So if you imagine that we've got, just to kind of type it in here, just to see, we've got point 1 and point 2, right? We've got those 2 lines, and then we find a point in between that is point 3. So the line was formed by point 1 and point 2. Now we've got 2 lines that are formed by point 1 and point 3, and then another line that's point 3 and point 2. So that's what we're doing here. We're increasing our line data array. And then that's it. We just keep on rocking and rolling until the greatest error that we found is smaller than our error threshold. So let's run this. There we go. Let's run this and see where we're at this point. All right. So it's actually not quite perfect. As you can see, we've got our blue points here. I'm gonna make. Actually, I'll keep it the same size. We've got our blue points, and so these are our data points, and we see that we've got one issue here. And actually, what happened is, if I looked into this point and this point, if I looked into to see what line it belonged to, it said it belonged to this line right here. And the reason is the way I defined my distance from the line equation. So here we've got a line, and what I do is I basically say the line is defined by the 2 endpoints. And so realistically, the equation for that line extrapolates it all the way to infinity in both directions. And so that means that if we extrapolate this line out this way, that distance from the line is 0, because it's right on it. It's right on the extrapolated line. So that kind of caused issues. So what I needed to do is I needed to detect if the line was inside of the envelope created by the 2 endpoints. So basically, if it was in between the 2 endpoints and not kind of out of bounds. If it was in the envelope, then I would just use the standard distance from a line to a point formula. But if it was not, then I would have to measure the distance between the 2 points, right? So I'd have to measure the distance from the endpoint. So that's the next change that I make kind of in the next scene.